Dr. Jim Green. Let's talk about 2022. It was a big year at NASA, big year in space. A lot happened. I think the most notable one that everybody remembers is Artemis 1, right?
Well, certainly Artemis 1 was a wonderful way to end the year. Launched in mid-November and well into December. It was doing all kinds of stuff, which is orbiting the moon, although it wasn't crewed. It had mannequins that were outfitted with the right kind of sensors, and it was throwing small sats all over the place, what we call CubeSats. And these CubeSats are doing all kinds of things. And so they'll be orbiting the moon, or they'll be flyby in the moon, and they're making really important measurements. So it was really an outstanding set of activities. And I think NASA did that so well. Once again, we made it look easy on something that is really hard, sending humans to the moon.
Yeah, it took a while to get off the ground though, right?
Well, it did, but you have to realize this is a brand new system. I mean, it's more powerful than a Saturn V, like 10% more powerful. And I don't know if you've ever seen a Saturn V, and I didn't, even though I was alive during that era of landing on the moon. It was so powerful, you could be a mile or two away and the ground would shake. So, it's a really powerful rocket, but that's what's necessary to be able to get us to the moon and then also get us to Mars. So it's just the perfect vehicle, and I think what we'll learn from this maiden voyage will be so much that it will make Artemis 2 and then Artemis 3 even more successful.
Awesome. All right, now let's talk James Webb, because these pictures coming out of this are amazing to even
They are.
non-scientists. Everybody thinks these are amazing and beautiful. So what are kind of the accomplishments of James Webb this year?
Well, the first thing you have to know is it's much bigger than Hubble, but it's also in a different wavelength. In other words, it's looking at light that even our eyes can't see. Whereas Hubble did indeed have a major part of the visible spectrum. So that means even with our most powerful telescopes here on Earth that look in the visible wavelengths at the same objects that Webb would look at, we never see what Webb sees. This is what makes it incredibly unique. And of course, it's got these huge big mirrors. It's about 7 times more powerful. So that when we look at the nebula, where stars are forming, we actually can peer right through the gas and where the dust is. And where the gas then accumulates and creates stars, the dust is creating planets. And so we're looking at these fabulous things forming in our own galaxy. But the main purpose for Webb was really to look back in time. So the further you look away from the Earth, the longer it's taken that light to get to us. And so that means it's really a time machine. And what it's looking for, it is starting to find these galaxies that were the first things made from the accumulation of gas that creates stars, then those clump to create galaxies. Now, the original thought was, well, after the initial start of the universe in an event we call the Big Bang, like maybe 500 million years, galaxies were forming. But we're finding out with Webb that's not the case. They actually formed earlier, maybe as early as 200 million years. So that means something about the universe was drawing it together, making these stars, but then the stars were accumulating into galaxies faster than we ever thought before. Then, not only that, we can look at the atmospheres of exoplanets. I mean, when I graduated from the University of Iowa, there was no hope of finding a planet around another star. That was just, nobody talked about it because you just couldn't do it. We're finding now more planets orbiting stars than there are stars in our Milky Way, and just an enormous number of planets. And now we're actually teasing out the chemical composition over that certain infrared wavelength band of the atmospheres of many of these planets. That's just mind-boggling.
It is mind-boggling. The world's just getting bigger and bigger, and it's hard to wrap our measly human brains around it. All right, let's move on to DART, because this was something that kind of shocked people. We didn't know that NASA was working on this, and all of a sudden, our world has become a Hollywood movie. So what happened with DART, and why was it important, and how was it successful?
Well, DART started when I was head of planetary science in about 2014, 2015. We started talking about planetary defense, defending this planet. Because what we were finding out is we were finding a large number of asteroids that have been thrown out of the asteroid belt that cross our orbit, and now we call them near-Earth objects that could actually hit us. And we're realizing it wasn't a matter of if, it was only a matter of when. And then, of course, the magnitude of the impact is going to be driven by the size of these objects. And we were finding huge number of objects with sizes that were bigger than football fields, all the way up to 30 or more kilometers in size. And they could be devastating. They could be city killers, or taking out continents, or literally taking out most of the life on Earth. So we got to the point by 2016 of saying, hey, we need to move forward with a mission that could actually start the process of learning how to defend this planet. The dinosaurs didn't have a space program, right? We do, and it's up to us to be able to take that challenge on, and make sure human life and the rest of the planet, life on this planet, survives. And we can do that by several ways. And the kinetic impactor idea came up at that time. It was a fabulous idea. And so we got our act together, got the funding from Congress and support from the administration and support from the administrator, and moved forward with it. DART was launched on October 10th, 2021. And so within, a year, we were hitting an asteroid and moving it. So this was pretty phenomenal.
And it was successful. We're good. We don't have to worry
Yes.
about, we don't have to have nightmares about asteroids. Okay.
Well, all I'm saying is we are analyzing the data. We actually moved it more than we thought we could. That's really good news. That means the size range, and this one was about 160 meters in size, a huge object, bigger than a football field, almost 2 football fields in size. And we moved it to where we could make that measurement of how much we moved it by. And so that'll tell us how big a size we're able to move over what distance. And that's not going to be the end of the story. There'll be some asteroids that are bigger than that and will be more difficult to move, but at least we've started the process of defending the planet.
Right. All right. So those are the big stories. What else flew under the radar this year that maybe didn't make big news? Some of the less sexy space stories that are still really important. Anything we should know about?
Oh, absolutely. To me, there's the beginnings, the middles, and the ends of missions, and each part of those processes are really important. And the end of a mission occurred this year. It was called InSight, and this was a fantastic mission that sat on Mars. It deployed the most sensitive seismic measurement we have ever deployed on any planet. And in fact, I don't think we've deployed many here on Earth that are as sensitive as the one we put on Mars. Now, InSight, landed like November 26th. I remember this because it was like Thanksgiving in 2018. I had to give up my Thanksgiving to be in the control room as we landed this beautiful platform called InSight, and then they plopped out the seismic system on the surface. And then it just started quietly making measurements. What was it measuring? Well, it was measuring Mars quakes. Why did we want to know about Mars quaking? Well, from quakes here on Earth, we can tease out the size of the crust, the mantle, and the core. It's one of those fundamental measurements we make to understand the interior of the Earth. So, but we didn't even know how much Mars would be quaking. It's a much smaller planet. Is it cool to the point where you're not going to have any internal movements of material that cause quakes? But we did know that, like here on Earth, there are Mars orbit crossing asteroids, and they hit the planet. And so maybe we could even see some of those things. Well, we saw all those things. And so since late 2018, it measured over 1,300 Mars quakes. And so we've been picking through the data, and it turns out we're finding some really unusual things that we have no explanations for. Mars has a crust, a mantle, and a core, just like the Earth does. Now we know their sizes. A little bit of surprise is that the outer part of the core is liquid. We didn't think that that was going to be the case. Our core, that's the outer part that's liquid, generates our magnetic field, and yet Mars has no magnetic field that is generated in the interior of the planet. So we're quite puzzled by why that's happening. But we're also finding that magma must exist in this crust. And in fact, in the volcanic areas like Elysium and where Olympus Mons is, and the really big the volcano on Mars that seem to be dead and dormant, well, there's magma moving around because there's a season for which we get quakes from that area. So it's really produced a lot of tremendous science. And as planetary scientists get really excited about understanding another planet that's Earth-like, because it tells us how these things get put together. What is the origin and the evolution of our own planet? We can tell by looking and comparing with the other terrestrial planets.
Wow. And speaking of origin, new news about the moon?
Oh, the moon has really surprised us. In the last 10 years, we're finding out many new things about the moon. And I think the most important thing that we have found out is that in the areas of the North and South Pole, there's craters that are hiding things. They're hiding these things, and they've hidden from us since the beginning of the space age. But now we're teasing it out. What's in those permanently shadowed areas that the sunlight can't shine into the depths of these craters in the North and South Pole turn out to be what we call volatiles. Volatiles are things like gases, or like water, and carbon monoxide, carbon dioxide. These things have accumulated in these permanently shadowed areas. Well, this is fantastic because that means that can be a resource for us. Water is water. We drink it here on Earth. It's H2O. It's a molecule of hydrogen and oxygen. We believe there's more than several 100 million tons of water in these permanently shadowed regions that's in frozen state, but that we can get. This is a wonderful resource for humans when we land on Mars to go get that water, because we can drink it, we can tease it apart, we can take the oxygen and breathe it, but we can also take the oxygen and hydrogen and create rocket fuel from it. And so it really gets us thinking about how we can use the moon, maybe in a long-term, more permanent way, well into the future.
Anything you're looking forward to in 2023?
Oh, absolutely. Another mission that I dearly love was called OSIRIS-REx. We launched it several years ago, and it has created a sample that is acquired from this huge asteroid called Bennu. Now, this is really an unusual asteroid because it's a carbonaceous chondrite. We think it's got some basic building blocks of life in that asteroid. Now, that's really an unusual concept. What does that mean? Well, that means we believe that after the Earth was formed, and it was really hot by all this material flowing together, it boiled off these volatiles, it boiled off all kinds of stuff. And then asteroids like Bennu hit the Earth and brought that stuff back and put it on the crust. And it has water in it, and it has amino acids, It has a lot of carbon compounds, and it might have provided just the right environment for life to start here on Earth. Now, many of those carbonaceous chondrites have hit the Earth and hit Venus and hit Mars and hit the moon, but this one is pristine and it's always missed the planets. And so we actually have an opportunity to go hunt it down, get a sample for it, and bring it back. And in 2023, that sample will return to Earth and we'll be analyzing it in our laboratories this time next year.
So right about this time next year?
Yep.
All right.
Yep.
We'll be waiting.
New discoveries will be coming out. You wait.
Man, a lot happened this year. It was a good year for space.
It was.
All
I
right.
enjoyed it. I had a great time.